So starting with first thing, remember period 3 also includes ionization energy. So the first part is, this is what happens when you move across the period. And let me also at the same time open a periodic table. So this is period 3, the third row. Starting with the first question, give the equation including state symbols for the first ionization energy of carbon. That's carbon. So carbon atom would be losing electrons. It should be gaseous. It's going to lose electrons and it would form gaseous carbon ion. So that is so one thing you have to be careful.
Sir.
Islam. So one thing you've got to be careful is it has to be a gaseous atom. Explain why sodium has a lower first ionization energy than sodium. So why magnesium? Magnesium is number 12. So magnesium is over here. This is what magnesium is. So why is it lower? Because what happens across the period? When you move across the period, why do the ionization energies generally increase? They increase because an atom has more protons. The number of protons increase, so there's more attraction for electrons when you move to the right. You have the same number of shells. Okay, that's another reason. They have the same shells, so the shielding remains constant. And the third part is that the atomic radius of the atom decreases when you move across a period. Because they have the same shells and you have more protons, there is more attraction for those shells. So the atomic radii decreases when you move across the period. So these are the three factors. So explain why sodium has a lower first ionization energy, or vice versa. You can say, why is magnesium having a higher first ionization energy? Because it's got more protons, same shielding, and the atomic radius is lesser. So there is more attraction for electrons. Second one is explain why magnesium has a higher. So why is there a dip at aluminium? So why do you have a dip at aluminium? And the reason for that is that it's the orbitals that magnesium has. The electronic configuration of magnesium is 1s2, 2s2, 2p6, and 3s2, while aluminium is 1s2, 2s2, 2p6, and 3s2, and then 3p1. So the electron is removed in aluminium from an orbital which is more shielded and has a higher energy level. So it's easier to remove that electron. So what you're going to write is an aluminium electron is removed from a higher energy 3p orbital, which is also more shielded compared to the 3s orbital in magnesium. So remember the dips. There'll be questions on the dips. What happens? Why is there a dip at group 3? So whenever you reach group 3, an electron is removed from a much higher energy 3p orbital, so it becomes easier to remove electron. The electron is kind of further away. And then, sorry, that's the answer to this one. Then explain why helium, neon occupy the two highest positions. So why do they occupy the highest positions in the group? Because they have the highest number of protons. So they have more protons within the period. So they will have the most attraction, more attraction for electrons. And that is the reason why the removing electrons would be more difficult. So the ones at the extreme top, they're always noble gases. They explain why the first ionization energy of argon is lower than that of neon. So what happens when you move down the group? So when you move down the group, this is what's happening. Okay, argon and neon. He's comparing argon with neon. So argon is over here, neon is over here. So what happens to ionization energy is when you move down the group, what happens is that the size of the atom becomes bigger. So they have down the group, you have greater atomic radius. Well, kiska answer hai, sorry. So argon and neon. So down the group, it becomes easier to remove electrons. Why? Because greater atomic radius, or the distance increases. Second factor, there's more shielding. So it becomes easier to remove electrons. There's actually one factor that goes against that. So you can add this, okay, despite the fact protons increase down the group. So two factors would suggest that it becomes easier to remove electrons when you're moving down the group. A bigger atom, the electron is much further away from the nucleus, and there are more shells. So it's shielded as well. So it's really far away. It becomes easier to remove electrons, even though it has more protons. ठीक है, ये सारा clear? Is the first question clear?
Yes.
Achha, so that was all about ionization energies. The next one is still kind of related to atomic radius. He's saying the first ionization energy of elements Na2Ar. Some physical properties show similar variations. The atomic radius of the elements decreases from Na to C. I'll give a brief explanation for this variation. So why is the ionization energy increasing? Sorry, decreasing actually. Na to Cl. So, I mean, that's the answer. When you move, when you have sodium just has 11 protons. But when you read Cl over here, why is it decreasing? Because Cl has 17 protons. So there's more attraction. You've got more protons, you're going to have more attraction. So more protons, more attraction, and obviously they have the same number of shells. The cations formed by the elements are smaller than the corresponding. Give a brief explanation for this change. So what happens to the cations? When cations are formed, the outer shell is lost. For example, if this is sodium, and if sodium were to form an ion, it would lose its electron. So why is the size going to be lesser? Because the outer electron would be lost. So when it's lost, the size decreases. So that's the simple explanation for that. Outer shell or valence shell is lost.
And sir, right, like therefore the nuclear charge is greater, or effect of the nuclear charge is greater.
Lekin in this case, he's not really asking about that. He's just asking, okay, I mean, yes, you can. I mean, you can say that. You can add that.
Okay, thank you.
But I mean, that's a good. Actually, that's a good point. Let me just quickly check W1123, right? It's probably just going to be a 1 mark question.
Sir, can you send these topical links in the group?
ठीक है, मैं सेंड करता हूँ इसके बाद. ठीक है. One second. पता नहीं कौन सा W1123, right? Just 1 second, very quickly. So that, so how many marks was this? Part 2, right? Or fewer shells. That's it. So he's given the following. Cation has fewer. So it was just for 1 mark, or just 1 second. How was it marking it? So cation has fewer shells. That's what we wrote. A proton number remains the same. Okay, that is one thing that we missed. Okay, it was a 2-mark. Did he clearly state that it was a 2-mark? This one was a 2-mark question. So valence shell is lost. The other mark was actually for the number of protons. Protons remain the same. Well, किसने कहा था? What word did you use?
I said nuclear charge.
Okay, that's the same thing. Not the effective nuclear charge, right? Just the nuclear charge.
Yes, yes.
Okay, it's a 2-mark question, so that was required. Okay. I said next one. Let's move to the next one. The oxides of the elements of the third period behave differently with NaOH. This is about the acidic and basic nature of their oxides and hydroxides. So let's just quickly have a look which oxides are basic, which ones are acidic. So यहाँ पे given है acidic and basic nature of oxides. So you've got sodium oxides and magnesium oxides. The first ones, they're basic. They would react with acids and they would produce salt and water. So metal oxides are basic. So that's the first part. So MgO is going to be a base, so it will not react with NaOH. That is not going to happen. It will definitely react with HCl. It will form MgCl2 plus H2O. That is what's going to happen. Aluminium oxide, on the other hand, that is the one that is amphoteric. It will react with both HCl and with NaOH. And it would form aluminum chloride and sodium. In the other case, it would form sodium aluminate. So that is what's going to happen. So with HCl, it will form AlCl3. So it's going to react with both. And with this, it would form NaLO2 plus H2O, and you can balance this equation. You probably did not need the second H2O, I think. Okay, this one was probably, and remember, there are multiple equations. There are multiple ways of writing this thing. I mean, this thing over here can also be written as hydroxides and oxides can be interchangeably used. This thing can also be written as NaAlOH4. So even in the marking scheme, there would be multiple options available. For example, this one, Al2O3 with NaOH, they've allowed NaLO2, NaLOH4, Na3LOH6 as well. So multiple options are already given. If we were using this equation, there was no need for this H2O actually. I mean, this H2O was completely redundant because one of the H2Os over here would get cancelled out. But remember, for Al2O3, remember this, don't get confused with the marking scheme. There are multiple options available for the equation. I say, anyways, SO2 with NaOH. Now, whenever you have SO2, that's SO2 is an acidic oxide. Okay, if we have a look at the, I mean, these last ones, they're all acidic, non-metal oxides. Or इसमें ये कि when you think of SO2, think of sulfurous acid, H2SO3. When you think of SO3, think of H2SO4. When you think of P4O6, think of H3PO3. So when you do a reaction of SO2 with NaOH, think of it as a reaction of H2SO3 with NaOH. It would form a salt and a water molecule. So in this case, SO2 with NaOH, it would form. Don't think of it as SO2, think of it as H2SO3. So the salt that would be formed would be sodium sulfide. It would be Na2SO3 plus H2O. Or यहाँ पे there would be no reaction. Okay, so remember this. Remember this part. Lots of questions would come on this. Okay, next one. That's again ionization energy. So we just did a similar question. So we can skip that. यहाँ पे आ जाते हैं conductivity वगैरह and melting points. So the first one, melting points. If you again have a look, I'll explain the reasons for that, for melting points being high and low as well. So the melting points, they look something like this. The first three are metallic. Na actually has a lower melting point, and the other ones, और यहाँ पे एक line draw कर लेता हूँ. If you want to divide them as low and high, it's probably going to look like this. Melting points below that can be considered low. Low and high is a relative reference. So below this can be considered low, and above this can be considered they can be considered high. They can be considered high. Na, the first three are all metallic. The first three are all metallic. Metallic bonding is something like this. It's a giant metallic lattice. And what happens is, metallic lattice, what happens in metallic lattices is, let me draw this. So what happens in metallic? हाँ जी.
सर आप थर्ड पीरियड करा रहे हैं?
हाँ.
ओके.
ठीक है. अच्छा, what happens
सर
in
वो
हाँ.
सर वो थोड़ा सा ब्रीफ थोड़ा सा समराइज करवा दे सारा.
नहीं, वो मैं कर रहा हूँ साथ ही. ठीक है. अच्छा, मैं बस metallic lattices का बता रहा हूँ कि what happens in metallic lattices is कि what is the attraction in metallic lattices? It's a regular arrangement of metal ions where you have positive metal ions and they are attracting positive metal ions attracting delocalized electrons. तो ये इनके बीच में ना attraction है. ठीक है, it's delocalized electrons being attracted by positive metal ions. But what happens is कि कुछ इस तरह होता है कि when you move across the period, ठीक है, तो Mg would be smaller in size. ठीक है, Mg का जो metallic lattice होगा ion होगा, that because it has more protons, so its metallic lattice would be smaller in size. तो वो ज्यादा थोड़ा tightly packed होंगे. ठीक है, they're going to be more tightly packed. So something like this. That is what Mg would look like. So when you move to aluminium would be even more tightly packed. Because it would be even more smaller. Because aluminium has 13 protons, right? So its metallic lattice would be even more. So it's going to be even more tightly packed. You can remember abhi humne kiya tha, across the period what happens is that the size of the atom decreases. So this is how aluminium would look like. Okay, they're all kind of the same structure. This is how magnesium would look like. Or ye jo hai na, this is what sodium would look like. Size decrease ho raha hai. Achha, plus delocalized electrons bhi zyada ho rahe hain. They're going to have a lot more delocalized electrons, these ones. Okay, iske andar there's going to be a lot more delocalized electrons. Or इसके ऊपर ना delocalized electrons. इसके अंदर भी delocalized electrons होंगे, but there would be slightly fewer. Can you remember aluminium has loses 3 electrons. It's got 3 electrons in its outer shell. So why is the metallic bonding becoming stronger? Because छोटे ions होंगे, they would have greater charge density. And if they have greater charge density, they're going to be more closer together. They'll be more tightly packed. And there's going to be more delocalized electrons, so there's going to be more attraction. Na के अंदर इतनी attraction नहीं होगी, ठीक है? So that is why the metallic bonds and the melting points are increasing, ठीक है? हाँ जी.
सर ये metallic radius like across the period decrease क्यों होती है?
वो ये था कि इसकी रीजन है कि number of protons ज़्यादा होते जा रहे हैं ना. When you move across the period, you have more protons, so more attraction for electrons. Shells तो वही है ना?
Yes sir.
मतलब shells भी
Constant shielding होगी.
हाँ, और ऊपर से isoelectronic है. Na और Mg और Al जो है, ठीक है, इसके पास भी 10 इलेक्ट्रॉन्स है, मतलब अगर ये आयन बना हुआ है, ठीक है, ये +2 आयन है तो इसके पास भी 10 इलेक्ट्रॉन्स है, क्योंकि 12 होते हैं, लेकिन it's going to be 10 and this is +3, so it's also going to have 10 electrons, right? ठीक है, क्लियर है?
Yes, sir.
अच्छा, और फिर ये कि यहां से यहां ना, ये भी याद रखना कि Na2Mg जो है ना, the strength doubles. ठीक है, the strength it doubles. अच्छा, why does it double? क्योंकि the number of electrons, delocalized electrons, they double. पहले Na was losing just 1 electron, Mg is now losing 2 electrons. Charge doubles and तो simultaneously दो चीजें हो रही हैं, चार्ज भी डबल हो रहा है, तो एक तो ये हो गया चार्ज डबल्स एंड इलेक्ट्रॉन्स डबल. तो the metallic bond becomes a lot stronger. There's a big jump in Mg. अच्छा, लेकिन Mg to Al ना, that is not the case. It's not doubling. कि यहाँ पे चार्ज क्या है, that's Mg is +2, इधर aluminium ion is +3. So it's not doubling. It's not doubling. So strength does not double. It just gradually increases. So यहाँ इस केस में ना strength slightly increases. Why? क्योंकि charge did not get doubled. मैं इस चीज को मैं फिर से एक दफा समझा देता हूँ, ये तो पेन ही सही नहीं लिख रहा. अच्छा, इस चीज को फिर से, let me just explain this quickly. अच्छा, first thing, why are the melting points increasing in MgAl? The reason is कि the first one has very less charge on its ion, +1, and there are very few delocalized electrons, so the attraction is obviously less. The second one, the charge has doubled. Mg is now +2, it's a +2 ion, and there's more delocalized electrons. So obviously there's going to be more attraction in the metallic lattice. Aluminium ke case mein, it's going to be the strongest out of the three. Why? Because aluminium has a +3 charge and it has more delocalized electrons. So there's going to be more mutual attraction between the ions and the delocalized electrons. Secondly, size become more. Na is bigger in size because it's got lesser protons. Aluminium is smaller in size, so they're more tightly packed together. So a number of factors why the metallic bond strength is increasing. लेकिन यहाँ पे there's a drastic increase between these two. हर चीज double हो रही है when you compare Mg with Na. But when you compare Mg with Al, things are not doubling. It's just a slight increase. Okay, this had a charge of +2. This over here had a charge of +3. So so the strength is not increasing drastically in this case. Is that clear? इसलिए ग्राफ का जो शेप है ना वो इस तरह है कि यहाँ से,
Sir?
हाँ जी,
सर मैग्नीशियम और सिलिकॉन में डबल हो रहा होगा?
सिलिकॉन तो टोटली डिफरेंट चीज है ना. सिलिकॉन इज अ जायंट कोवलेंट स्ट्रक्चर. ठीक है,
So,
Okay.
sir,
हाँ जी,
Na has a lower boiling melting point because the strength isn't that strong.
हाँ,
The strength isn't that strong.
yes.
Yeah, okay.
Mg has a much stronger strength compared to Na. But when you compare Mg and Al, they don't have that much of a difference. ठीक है, clear? जो यहाँ पे ग्राफ से नजर आ रहा है. ठीक है, clear है?
Yes, sir.
Achha, then you move to silicon. Silicon is right over here. It's at the top. Silicon, why is silicon? What's wrong with silicon? Silicon has a giant covalent structure. So it's got a large network of very strong bonds. It's a big giant structure, just like diamond. So obviously it's a very strong covalent molecule structure, macromolecular structure. फिर next रह जाता है ये तीन जो आखिरी तीन है. That's phosphorus, sulfur, chlorine, and argon. They are simple molecules. What is simple molecule? Simple molecule is
Van der Waals forces.
Van der Waals forces. So these have simple molecular forces. They're simple molecules, they're tiny molecules, and they don't have anything to do with each other except for with these weak van der Waals forces. So that's a Cl2 molecule. This is a P4 molecule. This is an S8 molecule. Sulfur is in the form of an S8 molecule. And argon is monoatomic. So van der Waals forces किस पर depend करती हैं? The bigger the molecule, the more the van der Waals forces, right? So van der Waals forces, they all depend on the size of the molecule. So what happens in this case is sulfur has the greatest van der Waals forces because it's the biggest molecule. And argon, it's a monoatomic gas, so it has the weakest van der Waals forces. They're all non-polar. तो इस टेबल को फिल कर लेते हैं कि कहाँ गया हमारा टेबल. मेल्टिंग पॉइंट्स. हाँ जी.
सर वो मेल्टिंग पॉइंट्स का ग्राफ दिखा दें.
ये वाला. क्लियर है?
सर इसके अंदर नॉन मेटल्स के अंदर कांस्टेंट फ्लक्चुएशंस आ रही है बार-बार.
van der Waals forces ना, सल्फर में van der Waals forces
अच्छा अच्छा.
सबसे ज्यादा,
Okay, sir.
आर्गन में सबसे कम है. तो वो उसी ऑर्डर में, remember this order because they're going to ask you, okay, why is sulfur having the highest melting point? Sulfur, remember, is a yellow solid. ठीक है, और सारों को पता होना
Yes,
चाहिए.
sir.
मतलब phosphorus जो है ना, मैं उनकी तस्वीरें भी दिखा देता हूँ just to be honest. Sulfur would look like this. Phosphorus दो types के होते हैं. अच्छा, sulfur जो है ना, that's a yellow solid, ठीक है. Among the non-metals, it has the highest melting point. Phosphorus दो types के हैं. There is it's a mineral. So my अच्छा, phosphorus जो है ना वो दो types के हैं. एक तो ये रेड phosphorus है, इसका बल्कि ना वो विकिपीडिया का काम पेज है, वो उसके अंदर गिवन भी है, नोट्स के अंदर ना ऐड भी है. इधर देख
सर आपने दिखाया था P4 रेड और P5 वाइट.
हाँ, नहीं दोनों P4 ही कहते हैं उन्हें. One of them is white phosphorus, the other one is red phosphorus. ये दो types हैं. One of them is white, the other one is red. इनमें से जो red phosphorus होता है ना, वो I think isomeric वो होता है, polymeric form होती है उसकी. ठीक है, यहाँ पे is this given somewhere? नहीं, एक सेकंड, यहाँ पे given होगा, next page पे ये given है, polymeric form. ठीक है, एक polymeric form है ये white और red phosphorus. ठीक है, उसी notes में given है. Phosphorus makes 3 bonds, so it's like a pyramidal structure with 4 phosphoruses bonded to each other. But then there is a polymeric form. What happens is कि जो इस तरह का structure है, that ends up forming bonds with the neighboring phosphorus, and it kind of ends up forming a polymer-like structure. कि बीच में एक bond यहाँ पे खत्म हो जाता है इनके बीच में, and they start bonding with the other one next door. So that is a polymeric form of phosphorus. So there are 2 types of phosphorus. हाँ जी.
सर एग्जाम में स्ट्रक्चर बनाने को कहेंगे वो.
ये polymeric form का आया हुआ है, क्वेश्चन आया हुआ है, although ये सिलेबस में नहीं है, लेकिन they did ask you for a question. उसके अंदर ना थोड़ा सा उन्होंने हिंट दी हुई थी कि polymerization की तरह के, कि अगर मेरे पास है तो although it wasn't in the syllabus, कि अगर मेरे पास है इस तरह करके ना वो रेड और व्हाइट phosphorus है, ठीक है, let's say phosphorus the बीच में वो, and there's this other, so how would a polymer form between them? तो जिस तरह alkenes में बनता है ना उसी तरह बनेगा. What will happen is, and this was an exam question, कि one bond will break over here. Now one of the phosphoruses are not making, I mean these phosphoruses over here, they're not making, they just made 2 bonds. So the third bond will be with the next door. ये भी next door, ये भी next door. ठीक है, clear idea?
Yes, sir.
कि जो white phosphorus है ना, that can turn into this red phosphorus, and that was an exam question. ठीक है, कि लेकिन वो था, वो कुछ questions होते हैं वो guesswork type होते हैं, you just use your common sense and try and figure this out. As anyways, quickly doing this low, this one is Mg is high, and
Sir? सर वो जो बॉन्ड ब्रेक करता है वो काइंड ऑफ P5 नहीं बनाता है इस तरीके से?
नहीं, P5 के सामने आ रहा है, अब तो वो पॉलीमर बन गया ना, अब तो इट हैज फॉस्फोरस 3 बॉन्ड्स बनाता है ना, तो वो भी 3 बना रहा है। पहले वो ये दोनों आपस में बना रहे थे बॉन्ड, अब इसे जाके उसका बना दिया। क्लियर है बात?
यस सर।
अच्छा, लो और लो, खैर वेरी हाई लिखने को उसने कहा ही नहीं था। कंडक्टिविटी, दैट इज सिंपल के Na is a metal, तो metal obviously they conduct, और conductivity में he has used the word moderate. Remember, silicon is a semiconductor, और ये लो है और लो है. So anyways, he was using the word moderate. अच्छा, anyways, next one. Conductivity का तो explain करने की जरूरत नहीं है ना, कि non-metals they usually don't conduct. Silicon is one which does conduct. It's like a, अच्छा, group 4 में ना metalloids होते हैं. Group 4, silicon is group 4. You start off with a non-metal, फिर carbon है, फिर silicon है, फिर I think germanium, tin, lead, शायद यही order है, ठीक है? That's group 4. Group 4 में ना down the group you become more metallic. पहले एक जमाने में ना group 4 कोर्स में होता है, top the group ना you become more non-metallic. तो remember this silicon is kind of like a metalloid. कि metal, what are non-metals? Non-metals like to gain electrons. What are metals? They like to lose electrons. So it's kind of in the middle. So why is it able to conduct electricity? Because it can lose electrons. It has a weak tendency to lose electrons. तो वो थोड़ा सा ना delocalized electrons. हाँ जी.
सर ये आप जो जर्मेनियम में सारा शो करे लेड, ये तो थर्ड पीरियड में नहीं आ रहा।
फोर्थ पीरियड है जी, थर्ड पीरियड में नहीं है, मैं वैसे एक्सप्लेन कर रहा हूँ कि ग्रुप 4 के अंदर ना मेटलॉइड्स होते हैं ना, मेटलॉइड्स.
यस सर।
कि वो देयर समथिंग इन द मिडल, इसलिए वो तो ग्रुप 4 मेटल और नॉन मेटल्स के बीच में आ रहा होता है कहीं. क्लियर है बात? उसके
यस
टॉप वाले जो होते हैं ना नॉन मेटल्स, बॉटम वाले जो होते हैं मेटल्स होते हैं. जैसा टिन और लेड आर मेटल्स. अच्छा, anyways, there's this substance E. For one element, E has the following properties. Its melting points are high and boiling point of the chloride is low. Element E was in the fourth period, one of the elements from gallium proton number 31. By considering properties of the third period element, aluminium to chlorine, suggest, तो ये कौन है? Which one is this? So melting point of this is aluminium. The melting point is high. ठीक है, so aluminium has 3 options है. Aluminium, magnesium or silicon. Like if you have a look at the chart, so there's just 3 options. उससे ऊपर वाले chart पे एक second. अच्छा, so you've got just 3 options. फिर वो कह रहा है कि उसके जो ऑक्साइड है ना, that is high. तो इन सारों के ऑक्साइड्स दे हाई. एल्यूमिनियम ऑक्साइड is ceramic, ठीक है? Magnesium oxide, they're both ceramic. They're very strong ionic compounds. ठीक है? They have very high melting points. You use them in furnaces. Or silicon oxide, that is, I mean, all three are actually, they're all 3 ceramic materials.
सर।
हाँ.
सर आपने भी कहा कि मैग्नीशियम ऑक्साइड जो होता है वो फर्नेस के अंदर यूज करता है। अगर फर्नेस के अंदर एसिड हो तो वो तो इसके साथ रिएक्ट कर जाता है ना?
हाँ, तो फर्नेस एसिड यूजुअली एक्वस होता है, तो आई थिंक फर्नेस के अंदर मुश्किल ही होगा कि वो एसिड जो इवेपोरेट कर जाएगा मोस्ट लाइकली. So HCl is most acids have very low melting points. Is that clear?
यस सर।
और हाँ, वो बात ठीक है. SiO2 जो है वो इट इज एसिडिक, तो ये बेसिस से रिएक्ट कर जाएगा. मतलब यहाँ पे दिया हुआ है कि SiO2 is, so every one is either acidic or basic. तो किसी न किसी के साथ तो रिएक्ट करेगा ना. ठीक है. अच्छा, but remember the point that all 3 have very high melting points. अच्छा, but which one of them have a chloride which has a low melting point? So the melting point of the limit is high. ठीक है, that's fine. The melting point of the oxide is high and the boiling point of the chloride is low. तो AlCl3 का low है, MgCl2 is an ionic substance. It is not low. SiCl4 is a covalent molecule that also has a low melting point. So SI melting point of the element is high, that's fine. MgCl2 बीच में से निकल गया. So remember this, कि chloride में ना, when you talk about chlorides, AlCl3 का ना वो dimerization खाता है ये वाला. So remember this, कि it's a AlCl3 is a covalent molecule, and it's capable of forming dative bonds, and it's capable of forming dimers. So remember this, Al otherwise forms ionic compounds, but in the case of AlCl3, it forms covalent molecules that dimerize. ठीक है, ये clear है? So
Yes, sir.
so the element E was in the fourth period and was the elements from gallium, proton number 31 to bromine. So let me, वो कह रहा है gallium से लेके ना bromine के बीच में कोई है. अब period C की properties क्यों discuss करते हैं? क्योंकि every period almost has the same properties. Like if you have any element in group 1, the bottom one is also going to have similar physical and chemical properties. Not identical, but almost or relatively the same. So aluminium or silicon दोनों इसके ऊपर fit हुए हैं. So gallium or germanium can both be your answers in this case, because both of them match the description. ठीक है, तो उसने कहा गैलियम और, तो आंसर क्या होगा कि ये दोनों तो एल्यूमिनियम, तो गैलियम एंड जर्मेनियम can both actually can both be this element in the fourth period. Is this clear?
So,
हाँ जी.
सर ये क्वेश्चन मुझे एक्सप्लेन कर दे, क्योंकि इसके अंदर कह रहे हैं कि प्रेडिक्ट द प्रॉपर्टीज ऑफ पीरियड 3 और फिर कह रहे हैं पीरियड 4, तो ये मुझे समझ नहीं आ रहा.
अच्छा नहीं, इसका मैं एक्सप्लेन कर रहा हूँ ना कि देखो पीरियड Mg की जो प्रॉपर्टी होगी ना, calcium will also have similar properties. Is that clear? And strontium would, I mean, elements in the same group have similar properties. Is that, ये पता है, ये clear है ना?
Yes, sir.
So if you're trying to figure out the properties of aluminium and silicon, तो उनके जो नीचे वाले elements हैं, they would also have similar properties. ठीक है? Is that clear?
Okay, sir. Yes.
अगर halogen होता तो bromine की भी almost it would also have similar properties, right? अच्छा, so remember this, that कहाँ गया हमारा? So the answer could be gallium or germanium in this case. Is that clear?
Yes, sir.
Let's see, बाकियों को clear है? Mine is okay. अच्छा, फिर ये oxidation number. You've got NaCl, MgCl, that's easy. कि oxidation number Na is +1, Mg is +2, Al is +3. Si is over here, because Cl is -1, remember that. So Si must be +4. Phosphorus is going to be, in this case, +3. And sulfur would be +2. So he's saying that by considering the electronic configuration of the elements, explain the variation. So the variation is Na to Al. So Na has one valence electron, which is lost. फिर Mg का बता दो कि Mg has two valence electrons which are lost, and so on. अच्छा, फिर इसका बता दो, why is silicon +4? Silicon has 4 valence electrons, so it ends up forming 4 covalent bonds. तो इसकी oxidation state जो है ना वो +4 है. What about sulfur? Why is sulfur +2? Sulfur is +2 because sulfur has 6 valence electrons, so it just needs 2. तो अगर वो sharing करेगा ना, it just needs 2 electrons, so it would form 2 covalent bonds.
So? सर वो आप अगर यही ऑक्सीडेशन नंबर का लाइक आप करा रहे हैं ना, तो इसके अंदर आप वो डिस्प्रोपोर्शनेट वाला करवा सकते हैं इसके अंदर?
अभी वो चलो उसमें कर लेते हैं, वो कंप्लीटली डिफरेंट चीज है, वो कर लेते हैं। पर मैं थोड़ा सा ऑक्सीडेशन नंबर का बता देता हूँ, ठीक है। रिमेंबर ऑक्सीडेशन स्टेट जो है ना, दैट इज फॉर Na2Al, that is the actual charge. Okay, if I write aluminium oxide या NaCl, then Na actually has a +1 charge, Cl actually has a -1 charge. ठीक है, तो NaCl. So remember, for metals, the oxidation state is the actual charge. For non-metals are covalent. They don't have charges. तो ये +2 का मतलब क्या है कि मैंने ऐसे कि sulfur is +2. What that means is कि chlorine is more electronegative. So what happens is these electrons are closer to chlorine. So when we try to find oxidation states, although they're not gained by chlorine, but they're closer to chlorine. So when we talk about sulfur and we talk about oxidation state, remember oxidation state is not the actual charge. It just shows the electrons, you know, who are they closer to. So chlorine is more electronegative, so you're going to state that they're closer to Cl. This one is also closer to Cl. So you're going to treat it as if it's ionic. This को आप +2 दे दोगे, Cl would be -1. The Cl would be -1, which is not the actual charge. Remember that. So actual charge and oxidation state is a different thing. Oxidation state just tells you if you have a bond, whether it's ionic or whether it's covalent, are the electrons closer to one of the atoms or are they closer to the other atom? In this case, the electrons are closer to Cl. So you're going to state that Cl is -1, H is +1. That's the oxidation state. The electrons are not actually gained by Cl. It's a covalent bond, but you're going to treat it as if it's ionic. फिर ये सोडियम क्लोराइड क्रिस्टल का ये क्लियर है, ये वाली बात पिछली?
यस सर.
कि metals के अंदर oxidation state means something else. Covalent molecules, the oxidation state means something slightly different. Now describe with the aid of a diagram what is the sodium chloride crystal. So it's Na+1. It's a regular arrangement of oppositely charged ions. Na+1 attracting Cl-1, Cl-1 attracting Na+1, which is then attracting Cl-1 and so on. तो बस एक दूसरे को ना अट्रैक्ट किए जा रहे हैं.
सर इसके अंदर डॉट एंड क्रॉस बना सकते हैं?
नहीं, he wasn't asking for that. He's talking about कि क्रिस्टल के अंदर बॉन्डिंग किस तरह.
ओके सर.
ठीक है. Type of bonding that's obviously ionic. मतलब sodium hydride में भी it's going to be ionic. Na is going to be +1, H would be -1. What is the oxidation number of hydrogen? That's -1, obviously. और यहाँ पे actual charge, this is actually -1 because the metal actually really loses electrons. ठीक है. Covalent में होता है कि they don't completely lose electrons. वो बस थोड़ा सा electron उसकी तरफ हो जाता है. ठीक है. अच्छा, यहाँ पे he's asking for the dot and cross diagram so you can pretty much do that. Oxidation number, he's asking for the oxidation number. Remember, H is +1. So in this case, H would be -1 because the metal, if you remember oxidation states, hydrogen is always +1 in compounds, except in metal hydrides when they are with metals. Because when they are with metals, then the metal is the one that loses electrons, and so hydrogen is the one that has to gain electrons. So Mg is +2. Mg would always be +2. Al is +3. अच्छा, pH3 में non-metals के साथ उल्टा हो जाता है. Non-metals के साथ when they are with H, so electrons are closer to the non-metal because they're more electronegative. So in that case, H is the one that loses electrons. So कैसा निकालते हैं oxidation state? H is +1 times 3. P is the unknown, that's X. सारों को add up करो, X would come out to be -3.
-3.
और इसमें भी ये करोगे तो it's going to come out to be -2. ठीक है. तो H का याद रखना, H जो है ना वो बीच में होता है. H इसलिए it's always floating at the top. It's always floating at the top क्योंकि ये बीच में होता है. Although it's a non-metal, लेकिन with metals it can behave as a non-metal. it can have a -1 oxidation state, and with metals, with non-metals, it will have a +1 oxidation state. तो वो यहाँ पे उसके बाद क्या कह रहा है, what is the pH of the solution formed in separate samples of NaCl? ये वो आ गया hydrolysis. ठीक है, this is hydrolysis. We'll just go through this very quickly. What happens when hydrolysis happens? अच्छा, hydrolysis में ये कि पहला वाला जो है ना NaCl, वो तो सिर्फ dissolve होता है. NaCl is the one when you dissolve, mix it in water, it only dissolves, the first one. ठीक है, you pretty much know कि NaCl, ये chloride की बात हो रही है, ठीक है, तो it just dissolves, no reaction, no hydrolysis, pH remains neutral, ठीक है, it's 7. अच्छा, Mg के केस में क्या होता है? Mg भी ना, it mostly dissolves but the pH is 6.5. Why? Because there's going to be some hydrolysis. What will happen is कि Mg has greater charge density. Mg has a +2 ion. When it dissolves in water, it attracts the water molecules very, very strongly. The water molecule को इतना strongly attract करता है that the positive H in the water is repelled by the Mg+2 and that gets knocked out. तो वो H+1 ना, it breaks off. ठीक है?
सर
हाँ जी.
सर MgOH2 तो वीकली अल्कलाइन सॉल्यूशन बनाता है जिसका pH 9 होता है.
नहीं, हम MgCl2 की बात कर रहे हैं. ठीक है, होता ये है कि Mg जो है ना, MgCl2 को अगर पानी में मिक्स करोगे ना, तो मोस्टली वो डिसॉल्व करेगा. इट विल फॉर्म Mg ions and Cl ions that would be floating in water, but the Mg ions will be attracting water molecules very strongly because it's got a +2 charge. तो वो H positive जो है ना, that's going to get repelled. It's going to get repelled, and the H positive ions from the water will get knocked out because of the repulsion from the positive Mg. तो MgOH2 बन जाएगा और सोल्यूशन में कौन सा आयन आ जाएगा? H+1, और Cl-1 तो पहले ही था, तो HCl फॉर्म हो जाएगा. Is that clear?
यस सर. नहीं सर, वैसे बेसिकली वो एक था जिसके अंदर MgOH2 बन रहा था.
नहीं,
weakly alkaline
MgOH2
solution.
अकेला अल्कलाइन होता है. It's obviously an alkaline, but it's insoluble, right? तो वो सोल्यूशन में से बाहर आ जाएगा. सोल्यूशन में क्या रह जाएगा? H+1. ठीक है.
ओके सर.
अच्छा, एल्युमिनियम क्लोराइड जो है उसका बड़ा स्ट्रॉन्ग हाइड्रोलिसिस होता है. व्हाट हैपेंस विद एल्युमिनियम क्लोराइड इज कि पहले तो इट मिक्सेस विद वाटर, डिसॉल्व्स, बट एल्युमिनियम हैज अ +3 ion. So the +3 ion attracts water molecules very, very strongly, and it repels the positive H very, very strongly. So all of these H+1 ions in water are going to be knocked out. Okay, they're going to be knocked out. The aluminium जो है ना,
Sir?
yes.
What repels the hydrogens?
See, this is Al+3, right? It's got a very strong
Yeah.
positive charge. So the hydrogen in water is already slight positive, right?
Yes.
So positive and positive, what will happen? The positive is going to be repelled, right?
Ah, okay, like that. Yeah, okay.
So वो water को ना hydrolyze करेगा. It will decompose water molecules. It will break them down, and that would result in the formation of aluminum hydroxide, and the H+1 will get knocked out. Is that clear?
यस सर.
ठीक है. Na के केस में नहीं था. Na के ऊपर the repulsion was very weak. Like, why doesn't Na hydrolyze? Because Na is +1. +1 is not a very strong charge. So there's just a very, very weak repulsion. ठीक है. तो इसलिए वो इतनी रिपल्शन होती है, the water doesn't hydrolyze. ठीक है, is that clear? तो इनमें याद रखना है कि Na almost no hydrolysis, Mg very, very weak hydrolysis, mostly dissolves. ठीक है, यहाँ पे लिखा हुआ भी है कि Mg जो है ना वो very slight hydrolysis. AlCl3, that's a strong hydrolysis. ठीक है. तो इस केस में ना pH would be 6.5, और इस केस में ना pH would be, let's say, 2. It's strong hydrolysis. ये बल्कि यहाँ पे pH की values शायद नहीं, strongly acidic. So is this
सर इसका pH 3 है.
नहीं, 2 ठीक है ना. वो तो आप रफ गेस कर रहे हो ना. बाकी वो क्लियर सारों को? माइन सिद्रा, is this clear?
सर
Yes.
तो like down the group solubility decrease हो जाती है
Down
like
the group,
across the period, sorry.
across the
Across
period,
the period, sorry.
हाइड्रोलिसिस ज्यादा होगा, वो मतलब यहाँ पे है ना, वो ट्रेंड फिर फॉलो होता रहेगा कि SiCl4 also has strong hydrolysis, PCl3, PCl5, they all have strong hydrolysis. और इतना strong होता है कि वो SiCl4, PCl3 have rapid reaction, releasing fumes of HCl, misty fumes of HCl gas बनके. ठीक है, is that clear?
Yes, sir.
So yeah, hydrolysis का suggests a reaction between sodium hydride and water. ये तो completely different चीज है. So what will happen when sodium hydride with water reacts? उसने did he? Now that's definitely not in our course, so he must have given some information. React with water. Really evolution of the same colorless gas G in each case. Same colorless gas. तो तुक्का लगाओ कौन सी gas होगी? Probably कौन सी gas बन सकती है? The only possible gas I can think of based on these elements is hydrogen gas. That's it. और वो NaOH बन जाएगा. Did he say? बस और कुछ भी नहीं बताया. So this is just guesswork. Suggest the pH of the solution form that's alkaline basic. So let's call that pH 12. Okay, that's basic. Here, character type of bonding is present in SCl2. That's a covalent molecule. That's simple covalent bonding. So we just have to tell the type. That's covalent. Write a balanced equation of the reaction of SiCl4 with water. So वो ये लिख देनी है कि SiCl4 with water ये it's SiOH4 or SiO2 plus HCl. That is what the reaction is. Hydrolysis will happen and it's going to react with water. It will form SiOH4 and HCl. That's it. चल ठीक है, कल कंटिन्यू करते हैं.
Sir,
Yes.
you don't need these state symbols?
In this case, वैसे
Yeah.
चाहिए होंगे. Remember, SiCl4 is a liquid. Just to be on the safe side, this is going to be a liquid.
So I mean, they are necessary, right?
This is going to be solid. मैं बताता हूँ एक second. And HCl is going to be a gas. So write a balance equation. 2 marks and check कर लेते हैं वैसे. State symbols वैसे usually when it's a 2-mark question, you should give us. If it's a 1-mark question, then no state symbols are needed. Okay, W09QP. 1 second. बस इसको जल्दी से देख लेते हैं. It's going to be 2-2. कहाँ पे क्या Na2Al, this one, right? हाँ मतलब इसमें नहीं वो 1 mark था actually. If it's 1 mark, no state symbols are needed. 1 mark वो पिछले का था covalent का, ठीक है? So just remember,
All right, sir.
I mean, use this rule. Okay, if it's a 2-mark question, 2 mark for equations only, then state symbol is needed.
Answer.
Huh.
For the previous question where you wrote alkaline in the mark scheme, it says 10 to 14. So if you just write alkaline, it'd be okay.
He was very. I think he was very specific that you had to tell the pH actually. So just a value for the pH. So I mean, that case, because that would kind of imply that you don't know what the pH of an alkaline thing is.
Oh, okay.
ठीक है, तो you have to be. I mean, you have to be very specific. फिर वो doubt में चला जाता है. Maybe you'll get marks, maybe you won't, depending on the examiner's whatever he thinks. ठीक है.
Okay.
चलें ठीक है. So okay, everyone, let's continue with this. ठीक है. और questions करेंगे.
All right, sir.
Okay, ठीक है.
Allah Hafiz.
Allah Hafiz.